Hello again. Yeah, I know, 2 videos in 1 week, but I had a question from someone on the vectorized implied volatility video, and he was wondering if you could modify that such that you are given the implied volatility and option price and you want to calculate a stock price. Not quite sure what the purpose of that would be. Maybe you have a model and you want to just calculate some sort of theoretical stock price given some sort of different type of implied volatility. But in any case, it's just a root finding problem. It's the Black-Scholes model as a function of stock price minus the option price is equal to 0. And you'll notice a theme running through pretty much all these videos that they all boil down to just a couple simple algorithms, root finding techniques, solving systems of linear equations, those types of things. Anyways, this should be quick, so let's just dive into it. Okay, notebooks. So I don't really want to spend a lot of time on this, so what I'm going to do is just borrow heavily from our vectorized implied volatility code. And I'm just going to grab our imports, put them over here. I'm going to grab, what am I going to grab? I'm going to grab our Black-Scholes code. I'm going to put it over here, run that. And lastly, our Newton's method code. So select all, copy. Let me actually put it above the Black-Scholes stuff. So insert cell above, run. Okay, I think we are done with this notebook. So I'm going to close it. We're not going to need this, so I'm just going to delete it. We're no longer going to need vega. However, we will need delta. So I'm just going to alter this function to calculate delta in its place. I'm only going to deal with calls just because delta for the call and put is has a slightly different formula, and I don't want to write the argument, pass through different arguments to deal with that. So I'm going to delete the put function. So let's just modify our call function to call objective function to handle stock prices. So that should be as simple as changing this to an S for stock price. And we're going to need to pass in implied volatility as an argument. And I'm just going to replace this first argument in this list as sigma. Okay, so let's see. Let's come down here to our call function. It's going to be the same thing. We're going to replace this with S for stock price. We're going to replace this with sigma. What? Our delta is just the cumulative distribution function evaluated at D1. So we need the D1s and D2s. We're going to change this from probability density to not continuous. What's the word I'm looking for? We don't need this either. Delete, run. Why am I drawing a blank on this? It's not continuous, cumulative distribution. So let's see, we have that. We have this. We have put price, call price. I don't think we're going to really need those. Oh, yes, we will. Yes, we will. So because I'm in a hurry, let me use the values from Apple that I used in the last video we did on the units and the Greeks. So let me just copy and paste those in here. Okay, so these are the values. Remember, we're dealing with a only 14 days to expiration here. Let me see. We want to create an argument, so args. These are our additional arguments that we are passing in. Is equal to sigma k r t and the call price, which is C0. Let me just make sure that runs. Excellent. Now we're ready to call our function, our Newton's method function. So let's come down here, copy and paste it in, and we should just be able to run. Yeah, 120. Let's look up the actual price from the previous notebook. So here was the screenshot of Tastyworks that I put into that. So let's just see what the price was. 120.96, and we got a value of 120.93. Pretty damn good. Oh, and I forgot to mention, where did I put that function here? Calculate delta. I had forgot to rename this function. It was calculate vega, so I've renamed it to calculate delta, and now it runs fine. Okay, this is pretty straightforward. It's just as I said in the introduction. It's just the same application of Newton's method to find the root of a function. So I'm not going to really bother with any sort of outro. I'm just going to clean this up, put it up on GitHub, just so there's a record of it, and call it quits. Okay, cool. See you later.